Hi everyone! Why do you think I'm filming this video while taking vitamins? This is because I want to show you how organics contributes to our life. This is vitamin C, obtained thanks to organic chemistry. It is packed into a plastic bottle, manufactured thanks to organics. And there's a picture printed on it by inks, produced via organic synthesis. Sounds a bit unreal, like organic chemistry entered so deeply into our life, but it is our reality. So in this video we will try to figure out why is the progress in organic chemistry so important even for a common man who has nothing to do with it at the first glance. How does the work of an organic chemist look like, and what do you need to go through to become an organic chemist? Let's find out together in this video.
Organic chemistry is what our everyday life is all about. We just don't really think about it, but almost everything you can see, touch, taste, and even smell contain organic substances. From petrol at the gas station and clothes at the store to the food we enjoy and medicine we take, everything from these substances is organic. There are over 20 million organic compounds known so far, and a huge number is to be discovered in the next 100 years. Impressive figures, aren't they? And of course, this enables the existence of the whole plenty of areas in industry and academic research where organic chemistry is applied.
But first, let's find out why organic chemistry is indeed a very unique field of chemistry. Have you ever played with a Erector set to construct, for example, a truck? Organic chemistry is the same thing, but in this case, scientists use simple building blocks based on carbon to construct complicated molecules with precise functionality. But one reasonable question still remains here. Why carbon?
It has a unique and useful property. Its atoms can form 4 bonds with other carbons or different atoms. This means that carbon can make chains in 4 directions. Like a skeleton in an organism, such a chain is the base of the structure and is called a carbon skeleton. Taking into account that we can add other atoms or groups of atoms to such a chain, alter its length and branches, we obtain a nearly infinite number of variations. And all of them will be included in the group of organic compounds. Of course, it would be hard to embrace such a diversity within only one scientific discipline. That is why we obtained more specialized fields of organic chemistry, like organic catalysis that was mentioned in the beginning, petrochemistry, polymers, pharmaceutical chemistry, and so on. Each of these fields requires a deep understanding of chemical processes which take place in nature or manufacturing procedures.
In other words, organic chemistry belongs to such knowledge-intensive areas where everything, be it academia or industry, starts from science. So what is the first step towards a career in chemistry and what to expect from the studies? We asked a student in organic chemistry how to prepare for studying organic chemistry programs.
When I started chemistry, I had no idea. I studied something before chemistry and I really started from zero. I literally only knew what an atom was. That's about it. And even only with that information, I still managed to get an A in my first organic chemistry lecture. You don't have to go into a medicine course and learn anatomy. You will never need it. But what could be the case is that at some point in your PhD career, you have to do something which is based on a medicine problem, and then you have to study that specific problem. But from my experience, when I talked to some PhDs, which basically did that, it really was never the issue. They understood it quite well. It was never too difficult, and all the difficult parts were still on the chemistry part. When you're in undergrad, for my university, I had in the mornings, I had class, and in the afternoons, I had lab pretty much the whole semester long. Now in my graduate studies or my master studies, I would say it is a bit more on the theoretical aspect. In my undergraduate studies, I had like a really strict script what I had to do. They basically gave me the script with, like, for example, 30 experiments experiments and told me, well, do this. This is really good in my opinion, because when you get into the research, so my first contact with research was with my bachelor thesis, they really expect that you know stuff and that you know how to do certain basics. Let me just say something. You're a chemist, so, and if you're going to go into organic chemistry, you really cannot be afraid of the lab. This is really, really bad. So you have to understand that you're working with really dangerous stuff, but you also have to understand that you cannot ever be afraid of it. You have to respect it, and you have to know what you're dealing with. You have always need to know, if something goes wrong, what do I have to do? I basically managed to explode a column. So at the top where you put your solvents in, you have like the glass container. I managed to make this explode and shatter into 1,000 pieces while I was standing beside it. And I was really lucky that I didn't get any cuts and only got a pentane ether shower.
Okay, imagine you have finished the studies and got all the basic needed skills. What's next? After the university, there are several options for an organic chemist. The main ones are academic research and working in industry. In both, a PhD degree is highly desirable, I would rather say compulsory. A popular employment website shows around 13,000 offers only for organic synthetic vacancies, while there is a lot more options if you have a degree in organic chemistry. In academic research, you can go with two areas: fundamental theoretical studies or applied organic chemistry.
Let's first talk about academic world of organic chemistry. Usually an organic chemist works in a team, and each lab has a specific topic of studies and works out the fundamental principles and details of a particular reaction or method. Later, this new scientific data is used in industry to predict the outcome of chemical processes and develop more efficient, cheap and green ways of synthesis and manufacturing. When you're experienced enough and ready to move on, you can take over the management of your scientific group or of the whole lab.
It is not only about universities and scientific centers where you can work as a researcher in organic chemistry. There's a whole branch in governments and industrial companies called research and development, which provides offers for scientific work. And it's easy to get lost among vacancies in different areas of manufacturing for an organic chemist. I will just show you a variety of opportunities on the slide. Food industry, domestic chemistry, petrol manufacturing, pharmacy, plastics, dyes, and there's even more. Of course, you can also find a place in other fields of chemistry or in related fields such as chemical analysis, chemical engineering, environmental chemistry, and also computational chemistry. All of them deal with organic compounds too. Many organic chemists are also doing their jobs in the fields close to medicinal chemistry. I mean, organic chemists are often engaged in drug development, so even those without medical education can contribute to our healthcare. How is it possible?
Organic chemistry is really present in almost all the levels of drug design. You cannot consider the process of drug design without organic chemistry. And this is because it really provides the logics for the molecular understanding of what is going on a drug or a potential drug on a lead compound. So you can easily, I would say, divide the first part as the interface with physical chemistry, with theoretical chemistry, when you have to evaluate important aspects like lipophilicity, drug metabolism, and so on. And then before testing the biological evaluation, you need exclusively the knowledge in organic synthesis for preparing the compound. And this drug is just the result of a sequences of organic operations. And this is why an organic chemist or the knowledge in organic chemistry becomes fundamental for the process of drug design. I think that a solid and robust education in organic chemistry really offers you all the skills for being successful in drug design. But just with the education in synthetic chemistry, in my opinion, you would not be completely proficient in managing the drug design process. My strong recommendation is implementing the synthetic background, which is furnished in a brilliant way at the faculties of chemistry, with biochemical knowledge and, most importantly, with some medicinal, pharmaceutical subject. Because in this way, you would have like a much more clear panorama, much more portfolio of tools that before or after will be important for the successful management of your project. I think already in life, having a PhD helps. It depends also because when you enter in a company, of course, you have not an high-level responsibility position. But if you really consider yourself talented enough to go up on the ranks of the research organization of the industry, having a PhD makes highly qualified for securing the objective. Also because having a PhD somehow would also facilitate the contact with academia. There are a good connection between academia and industry. And depending on the personal motivation, if you really look at becoming an important member of the research academia in industry, a PhD would really benefit.
Where else would a degree in organic chemistry be useful? We live in the 21st century, computers are everything. The same is true for modern organic chemistry. People need special software, calculations and modeling problems, and here we go.
Some of the researchers go even further and combine programming with organic chemistry in their work. This is how molecular modeling, computational chemistry, and software development in organic chemistry evolves. Today, every organic chemist uses chemical software for calculations, analysis, drawing, and prediction. The rise of computer performance allows us to do all this more effectively. So those chemists who can develop new programs, computational methods, and software enjoy a high demand.
One of the most prominent specialists in computational chemistry told us about why more and more people are turning to computational chemistry right now.
So my PhD was in the early 90s, so end of the 80s, early 90s. So computers came up and I recognized the potential of doing chemistry on the computer. You have much more freedom to choose your subject, your topic, your favorite system when you have the computer, so kind of virtual spectrometer, than if you're doing it in reality. In reality, it's also always so difficult. It's dirty and dangerous and costly and so on. And in the computer, it's relatively easy to follow new ideas. The first thing is that you can design properties, basically. You're looking for a substance that has this or that property, small or large homo-LUMO gap, big binding affinity, or is extremely flexible or extremely rigid. Then this can be tested before synthesis, before you even think about a synthesis in the computer. And so these relatively simple properties, or standard properties, are so easy to compute and so accurate that that should be done. And you can do this in a massively screening way. So you screen thousands to millions of compounds that are automatically generated. and that lead your intuition or your chemical thinking maybe in new areas, just by looking at the properties of millions of compounds that have been computed. So it helps us with our way of rethinking chemistry or intuition. So you have a target property, you want to do something, some function, you want to implement with your molecule or your solid or whatever. And then you really take computational chemistry beforehand as a tool. So all the big companies have computational chemistry groups. BASF, for example, has a big group with 20 to 30 people or so. 2 of my PhD students recently were hired by BASF. So definitely the industry knows or now sees the potential of applying computational chemistry, or in a way replacing costly and inefficient procedures, experimental procedures, by computational ones, which are cheaper, cleaner, mainly cheaper.
Okay, now you have the idea who you may be with a degree in organic chemistry and how this work looks like. But what if you feel that neither science nor industry is good for you?
Not a reason to lose heart, because there are many alternatives for organic chemists in the areas of education, consulting, medicine, media, marketing and sales, and the list is far from over. But these jobs are less about organic chemistry and more about other skills like management, communications or administration. But if you are gifted enough, why not try your hand at other areas?
Well, I hope this video made it more clear what horizons will be open for you if you make up your mind to be an organic chemist. It's a broad discipline which has an application literally everywhere, but at the same time requires really much experience, inspiration and carefulness. You can put your finger up if you like this video and write in the comments what field of organic chemistry is the most interesting for you. If you want to know more about chemistry, find chemistry fellows, work, or just have some fun, you are welcome to our chemical forum. See you soon. Bye.